Seriously though, how cool was that? That's my can. I'm sure the dozen that you did after chugging down the pop just so you could get the cans look pretty similar. Uh, yeah, it's pretty cool. So the key to this is that we had a little bit of water in that pop can, and as it got heated, it turned into steam. So when water turns into steam, basically what happens is its volume increases by about 1,000 times. So this tiny little bit of water turns into this much uh, gas pushing outward. So what would actually make the can implode like that? Because really, if you flip it over upside down, you have that gas pushing outward. Would that make it explode? And that would be really dangerous. So you have to look at what starts to happen as soon as that gets turned upside down, where all that gas and steam is now trapped. What does that gas really want to be? Well, water in regular room temperature wants to be water. It wants to be liquid. It's not going to naturally be that crazy excited gas with the particles moving all over. It wants to be the nice little liquid with particles moving more slowly. So once it gets into that ice water, it goes from crazy gas that is 1,000 times bigger, and it shrinks down to the cooler water with the slower moving particles. And so instead now of pushing out on the can like it had been doing, now it's sucked back in. Meanwhile, the air pressure outside the can had been pushing out on it the whole time. So you have air pressure right now pushing on you. You just don't notice it. But if you were somehow able to pull air out of something, that's when you really start to feel that air pressure. So when you pull the air out of the can, as that steam turned back into water, reducing the outward pressure, that's where we get an unbalanced force. So we go from chemistry to physics. So if instead of the force being outward so much, now we barely have any force out, it's shrinking down, we have a lot of force in, that's what ends up pushing the can and instantly squeezing. It happens really, really fast because it goes very quickly to go from the 1,000 times big gas to the tiny little water that we had. So overall, this idea is kind of helpful for a lot of things, like why do your tires lose pressure when it's cold outside compared to when it's warm? Same idea, it's instead of steam turning into water, it's just gas that instead of moving around all excited like the way the particles do, this is my particle dance by the way, instead of moving around so excited, they're moving around a little bit less, so they're not pushing out as much. If they don't push out as much, the tire isn't as inflated, the air outside is pushing in more, so that's why your tires get kind of squished down. So lots of uses that you can actually see for this kind of lab. So it's a really good one that it kind of is more involved with your daily life than you might think. Plus, it's awesome.